Let us take another problem on equilibrium. It is a connected body cable problem, model question paper VTU. Determine the forces in the cables. So this is the system, cable system he has given. Here he has given a weight of 30 kN at joint A. So there are 4 cables here. You can see CB, BD, BA and AE. 4 cables are there. So we have to find the forces in the cables. So as I already told, forces in the cables will be in the form of tension force. So I will assume the tension forces as T1, T2, T3 and T4 like this. Now you know that the tension forces will be acting away from the joints. So C is the joint here. Tension force it should act away from C as well as away from B like this. So T1 will be acting like this. Similarly T2 it should act away from B and away from D is like this. T3 away from B and away from A. T4 away from A and away from D like this. So these are the forces, tension forces acting at those 4 cables. So T1, T2, T3, T4 they are the tension forces in the cables. So those are the unknowns now. So there are 4 unknowns. So we need 4 equations to solve for those 4 unknown forces. So as you know, we have to consider the equilibrium of the joints, and at the joints we have to apply the equilibrium equations, and we have to find out the unknown forces. Now since we need 4 equilibrium equations here, there are the joints where the cables are meeting, those joints we have to consider. Here A and B, they are the joints, where at A you have 2 cables meeting AE and AB. So there are 2 unknowns if you consider the joint equilibrium of A. T3, T4 they are the unknowns. And similarly if I take the joint B, you have 3 cables meeting at joint B. CB, BD and BA. So 3 unknown forces will be there, T1, T2 and T3. Since we know that at a joint for a concurrent force system we have only 2 equations of equilibrium, sigma Fx0 and sigma Fy0, we cannot consider joint B first because there are 3 unknowns. We cannot solve using 2 equations of equilibrium. Therefore first we will consider joint A. So FBD of joint A I will consider first, because only 2 cables are meeting at joint A and only 2 unknowns are present. So let me write the joint A FBD. You have a vertical load given 30 kN at A, and AE is a horizontal cable. So in that cable you have a tension force of T4 acting away from A like this. Then you have at AB you have a tension force away from A like this, T3 tension force is acting like this. Of course this is making an angle 60 degrees with the horizontal. Now this is the free body diagram of joint A. So free body diagram means you have to write the forces acting at that on that body, and also we have to write the weights whatever is applied there and the reactions. Of course here that body is nothing but this joint A, and you know that you can see here T3, T4 they are the unknown forces here. Now we can solve this problem either by using Lagrange's equation, because only there are 3 forces acting at the point A, concurrent forces, or you can use sigma Fx0, sigma Fy0. So now let me take the equilibrium equation. Sigma Fx is equal to 0, forces acting towards right positive. So for that we have to resolve the forces. Only this force we have to resolve because it is inclined. So if you resolve this T3 force, horizontal component will be like this, vertical will be like this in the second quadrant. So this is T3 cos 60, this is T3 sin 60. Now if I apply sigma Fx is equal to 0 equation for this joint A, so what you will get here is T4 is acting towards right now, that is positive. T3 cos 60 is negative because it is acting towards left. That's all. So this doesn't have any horizontal component. This should be equal to 0. Now, or in other words, T4 is equal to T3 cos 60. So this is the first equation you got. We cannot solve this because there are two unknowns. Next, second equation, sigma F1 is 0. We are going to apply at the same joint A, treating upward force positive, downward force negative. So this T3 sin 60 is upward, so therefore it is positive. Minus 30 kN is downward, so negative, is equal to 0 because this doesn't have, T4 doesn't have any vertical component. So from this we can get T3 as 30 divided by sin 60. So if you simplify that, you get 30 divided by sin 60 is equal to 34.64. 34.64 kilonewton because the weight is in kilonewton, tension also is in kilonewtons. So this is the tension force acting in the table AB, that is T3 value. Once you get T3 value, substituting for T3 in equation 1, you can simplify for T4. T4 is T3 cos 60, that is 34.64 cos 60. So cos 60 is half, therefore half 34.64 into half is 17.32 kilonewton. So this is the tension force which is acting in the cable AB. So T3 is the tension force acting in cable AB. And in cable AE, the tension force is 17.32. Now we have to get the values of T1 and T2. So for that we will consider the free body diagram of the next joint, that is B. First we cannot take B because there are three unknowns and we have only two equations. We cannot solve. Therefore, first we consider the joint where only two unknowns are present. Now at B you have three cables, BC like this, BC. So tension force in that away from B is T1. So we have to take away from B because B is the joint under consideration. Then BD you have tension force away from B, that is T2 unknown, making an angle 60 degrees with horizontal. Then BA, so BA, that is also making an angle 60 degrees with horizontal. This is 60, this also will be 60, alternate angles. So this force is acting like this is T3, which you have found out. T3 is equal to 34.64 kilonewton. So they have not given any force acting at B, weight acting at B. Therefore, B joint is free now, free there. So 34.64 is the force in the cable BA. Now this is the free body diagram of joint B. So for this joint, let us apply the equilibrium equations. Sigma Fx0, forces acting towards right positive. So here we need to resolve both T2 and T3 forces because they are inclined. So T2 force if you resolve, so it will be is the first quadrant. So T2 cos 60 towards right and T2 sin 60 upwards. Then if you are resolving this T3, so it is in the fourth quadrant. So if you resolve T3, that is T3 is known now, 34.64 cos 60, 60 degrees is the angle with the horizontal, and the vertical is 34.64 sin 60. So these two we have resolved now. T1 doesn't have any vertical component because it is a horizontal force. Now if you apply this equilibrium equation, sigma Fx is equal to 0 for this joint B, T1 is acting towards left, therefore minus T1. T2 is at the horizontal component of T2 is plus T2 cos 60, it is acting towards right. Then horizontal component of 34.64 is also positive, so plus 34.64 cos 60 is equal to 0. So this is the equation. Now here, so this minus T1 plus T2 cos 60 means it is 0.5 T2 because cos 60 is half plus cos 60 is half means it is 17.17 34.64 means 17.32 is equal to 0. So this is one equation. So we call this as equation 2. Next, I will take the next equilibrium equation to be applied as sigma Fy is equal to 0 at the joint B, upward forces positive, downward negative. This doesn't have any vertical component. So this is T2 sin 60, which is positive upwards, whereas this is negative. Minus 34.64 sin 60. This should be equal to 0. There is no external force given at B, joint B. So now from this you can get T2 value. T2 is, so this sin 60 can be cancelled out. T2 will be 34.64 kilonewton. So this is tension force in the cable. T2 means it is in the cable BD. This is the tension force in the cable BD. So this value of T2, you substitute in equation 2, you will get T1. Substituting for T2 in equation 2, so you will be getting T1 as T1 if you bring to the RHS, so 0.5 times T2 plus 17.32, so which is 0.5 into 34.64 plus 17.32, which is 34.64 kilonewton. So this is the tension force in the cable T1 in the cable BC. So these are the tension forces that are going to develop in the cables to sustain this load 30 kN. So the entire system will be in equilibrium, and by applying the equilibrium equations for the joints, at the joints, you can always find out the tension in the cables. Now the answers, so all of you please try to solve the problem on your own and try and check the values, answers. So T1 we got 34.64 kilonewton. T2 also 34.64. T3 we got the value of T3 also 34.64. See, all these three are equal, but T4 value is 17.32. Only 17.32. Only T4 value is different. All the other three values are same. So this is a simple problem, of course, given in the model question paper. Now I will take one more problem in the model paper, a sphere problem. So this is also a question in the BTU model question paper in the last year. So the question runs like this. Draw the free body diagram of the sphere shown below and determine the reactions at the points of contact using Lami's theorem. So here there is a sphere here. This is a sphere. So the weight of the sphere is given as 1 kilonewton or 1000 newton. 1000 newton or 1 kilonewton. This is center of gravity of the sphere. So this weight of course always acts vertically downwards. Now this is resting on two inclined planes. Resting on two inclined planes. That is what he has given. Figure is given. But the angles are different. So these are the contact points. A, B are the contact points. This angle is 45 45 degree, whereas this angle is 30 degrees. So the angles of the inclined planes are different. Now the question here is, we have to find out the reactions at the points of contact using Lagrange theorem. So find the reactions at contact points. So contact points become the support. Here the contact points are two, A and B. Using Lagrange theorem, he has specifically asked. So either you can solve using equations, or we can use Lagrange theorem. Of course, here he has specifically asked analyze the problem using Lagrange theorem. So let us use Lagrange theorem only to solve this. So for applying Lagrange theorem, we need to have the angles between the forces, concurrent forces. So since the reactions here, assuming that these surfaces are smooth surfaces, please note that these surfaces, both the surfaces are smooth surfaces. Smooth surface, this is also smooth surface. So when the surfaces are smooth surface, the reactions developed at the contact points will be normal to the contact surface. So that is very important. Here A is the contact point. So this is the contact surface. So whatever reaction develops at A, it will be at right angles are normal to this contact surface. That means it will be something like this. This is the reaction at A. This is very important, 90 degrees. This makes an angle of 90 degrees. And also this reaction, line of action if you produce, it touches this center of gravity of this sphere. Similarly, the reaction at B will be normal to this contact surface like this. This is RB, reaction at B. This angle will be 90 degrees, and if you produce this line of action of the reaction, it will pass through the center of gravity. That means here RA, RB, and also this weight you can take W. These three are coplanar concurrent forces. You can take coplanar concurrent forces, so that the three forces are there. You can apply Lagrange theorem. So this is very important. So please note that reactions at contact points. In this case, there are two reactions, RA and RB, are normal. Normal means at right angles. At right angles to the contact surface. That is very important point. Of course, this holds good in the case of smooth surfaces. Even if they don't give, you can take it as smooth surface. Otherwise, they will give friction coefficient. Then it will be a rough surface. Now, all these three RA, RB, and W, which is nothing but the weight of the sphere, constitute a coplanar concurrent force system. These three forces keep the sphere in equilibrium. So we can apply Lagrange theorem because three forces are there and the sphere is in equilibrium. So let us write down the free body diagram of sphere. There is also a free body diagram of sphere also. So if you want to write the free body diagram of sphere, we have to remove the contact surface, replace them by the respective reactions, and also include the weight of the body, then you will get the free body diagram. Now if I take the sphere like this is the sphere, center of gravity is G, is the point of concurrence. So you have weight of the body acting like this, which is 1000 Newton, he has given that. Then reaction RA, I can write like this, RA reaction, it is making an angle 30 degrees, so like this. So this is RA. This RA you can extend, okay, like this. Then RB, it will be like this. These angles of suppose he has given this angle is 30 degree and this angle is 45 degree, that is given in the problem. Now when that is 30 and 45, so now what happens here, if this is 30, this will be 30, this will be 30. So that means if you extend this line of action like this, if you extend that, so what happens here, if you draw a horizontal here, this angle will be how much? So since this is 30 and this is 90, this becomes 60. So be careful about the angles here. When this is 30, this is 90, this becomes 60 because total should be 180. So therefore this angle will be 60. Be careful, right? 60. Similarly on this side, if you take this angle as 45 degree, if this is 45, this will be 45, this will be 90, this also will be 45. What I do here is this line of action also I will extend like this. If I extend like that, so this angle becomes 45 degrees. So why I have done like this is, let me show this by three concurrent forces because I have to apply Lami's theorem for this. So G is, this is point A, this is point B. Now what I do here is, G is the point of concurrence. At this point D, three concurrent forces should act. So the first force I will take W like this, 1000 Newton acting vertically downwards. Then second force I will take RA like this. Please note away from the point because this reaction can be extended, and you know that according to the principle of transmissivity of force, along the line of action of the force, the effect of the force remains same at whatever point you consider along the line of action of the force. So this becomes RA. So be careful about the angle. So this is 45 degrees, 60 degrees. That's what I have shown here, 60 degrees. Similarly, another force RB I have extended like this. This is RB reaction, whereas this angle will be 45 degrees. I have proved that. So this is the diagram for applying Lami's equation. So because we need the angles between the other forces. So as per Lami's theorem now, any force divided by, for example, 1000 Newton force is there, divided by sine of the angle between the other two forces. So 1000 Newton is this force. Angle between these two forces will be now, so this is 60 plus 45, 105, 180 minus 105, 75 degrees. So sine of 75 degrees. Angle between this is equal to, second force I will take RA divided by the angle between the other two forces is this angle, which is 45 plus 90, 135. 135, sine 135 degree. Then is equal to RB divided by the remaining angle. So remaining angle is sum of these two, that is 75 plus 135, which is 210. 360 minus 210, that is 150. So sine 150. So this angle will be definitely. So this is RB divided by sine of the angle between other two sides is 150 degree. Sine 150 degree. Now this is the Lami's equation. You take the first two and the first and third to get the unknowns. So first two, if I take 1000 divided by sine 75 is equal to RA divided by sine 135. So from this you get RA as 1000 into sine 135 cross multiplied divided by sine 75 degree. So that is the answer for RA. So the value is 1000 into sine 135 divided by sine 75. Using calculator can get it 732.05. So Newton, because the weight of this square is in Newton, the whatever force consider you are going to get reaction answer also will be Newton. Now consider first and third. So 1000 divided by sine 75 is equal to RB divided by sine 150. So from this RB will be equal to 1000 into sin 150 cross multiplication divided by sin 75. Now if you do this multiplication, 1000 into sin 150 is equal to divided by sin 75. This will be equal to 517.64. 517.64 Newton. So this is the reaction that is going to develop at B, and this is the reaction that is going to develop at B. So reaction at A is 732.05, which acts normal to the contact surface. Here this is the reaction acting at B. Of course, the same problem can be solved using the equilibrium equations also. You will get the same answer. So sigma fx is equal to 0 and sigma fy is equal to 0. If I apply for this, you will get two equations. Two unknowns will be there, RA and RB. So if you solve them, you are going to get the same answer. So you are going to get positive values. Please note that the directions of the reactions, whatever you have assumed, is correct. If you get any negative value for the reaction, then the reaction is acting in the opposite direction. That is the meaning. So if you assume RA in this direction, let us say in this direction, then you are going to get RA negative. So that means your analysis is okay, but the direction of the reaction force is different. So always remember that when you get force value negative or reaction value negative, its direction is in the opposite direction. That is the meaning.